So let's start. Let's begin. And so we did an intro of what you're going to study in AS. Okay, that's P1, P2, P3, and we listed physical chemistry, where you had mathematical concepts and it was more conceptual. You had the memorization of facts, that part, which was inorganic chemistry, and then you had the very difficult organic chemistry right at the end. Remember, this one is going to be extremely it's going to be very challenging. I mean, in AS, organic chemistry specifically is the one that is kind of hard. It's hard. So we'll start with the first one, which is equations, stoichiometry, and moles. And I told you that pretty much everything is, exactly the same. There is no new concept except for one thing, and that is that the questions are going to be a lot harder. I mean, a lot of them, not all of them, a lot of them would be exactly the same. They would have exactly the same difficulty level, but definitely harder compared to your O levels or IGCSE. So, and with the concepts, I'll be quick. Just a second. So this. So first thing, before beginning in moles, we'll have a quick revision of all the equations that because remember, you can't do moles if you don't know how to actually write an equation. So we'll start off with equations, and even before equations, you must know what a formula is. I'm not going to go into a lot of detail about how those formulas happen and all the ionic compounds and covalent compounds. We're not going to deal with that at the moment. We'll just be quick at the moment. So you've got two types of compounds. I'm pretty sure you know what an ionic compound is. Now in an ionic compound, and I'm only interested in the formula, not about the properties or anything. So ionic compound is made up of a metal and a non-metal. The metal happens to be the positive ion normally, and the non-metal happens to be the negative ion. So if you've got a positive ion, you've got a negative ion. So you must know which atom has what charge. So for example, does anyone know what is the charge of a group 1 atom? Any atom that belongs to group 1, what is the charge of that?
+1.
Okay, that is going to be +1. You've got group 2. And that's going to be +2. Okay, so I'm assuming all of you know this. Group 3 is going to be +3. You've got transition metals, and they have variable charges. So they could be, just a second. I said they could be, now transition metals could be, they have variable charges. It's written in the formula. So for example, you've got iron 2. So when it's written in Roman letters, it's iron 2, then it obviously means it's +2. If it's iron 3, that's +4. If it's tin 4, that's, if it's written tin, and it would be written in Roman, so that means Sn has a charge of +4. So transition metals, their charges would be written. Now, coming back to non-metals, what's the charge on a group 5 element? You get group 5 is?
-1.
Group 5 is not -1. Group 5 has...
Is it -3?
It's -3. It has 5 electrons in its valence shell. And to complete 8 electrons, it needs 3 electrons. So it's -3. Don't worry, we'll discuss this. When we study atomic structure and chemical bonding, we'll discuss the charges in a lot more detail. But right now, just remember that group 6 is going to be -2. It already has 6 electrons, and it needs 2 electrons. Okay, you've got group 7, and that's going to be -1. So these are your main groups. So we can take this as a rough guide to figure out what the charge on the elements are. So for example, and then you have another thing, which is the crisscross method to figure out the formula of a compound. So there's going to be a positive ion and there's going to be a negative ion. So if you have, let's say, aluminium, it's in group 3. What is the charge on aluminium? It's
Plus
in group
3.
Okay, so that's +3.
+3.
And I've got oxygen. I've got a negative. I've got non-metal, which is oxygen. And what is the oxygen is in group 6. So what is the charge on oxygen?
-2.
Okay, that's -2. Does anyone know what the formula is, or how do you figure out the formula?
It's going to be Al2O3.
Okay, so what happens is that I mean the simple shortcut is I'll give you just a brief description of why the crisscross works. Because aluminium is a metal, it loses how many electrons? It loses 3 electrons. It's got 3 electrons in its outer shell. And oxygen over here is in group 6. It already had 6 electrons. It gained 2 electrons. Now, the positive ion and the negative ion, they obviously attract each other, which is why they're together, which is why they're forming an ionic compound. But the electrons lost and gained are not equal. Because this is losing 3 electrons, that is gaining 2 electrons. So that's obviously not equal. So they need to be balanced out, because where are the extra electrons going? So the crisscross method it's a simple shortcut that if there's 2 written over here, that means there's going to be 2 aluminiums. If there are 2 aluminiums, that means that there are a total of 6 electrons that are lost. And if there's a 3 written over here, oxygen is going to be 3. If you have 3 oxygen atoms, then the total electrons gained would also be 6. Because 1 aluminium loses 3 electrons, 2 aluminiums would lose 6 electrons. 1 oxygen gains 2 electrons, 3 oxygens would gain 6 electrons. And therefore, the formula is going to be Al2O3, okay, as you just said. It's going to be Al2O3. So I'm assuming everyone knows this. You know, at least we'll do the background thing, the atomic structure, chemical bonding much later, but yes, that is what we are trying to do by multiplying or taking. Instead of, actually, since I don't do math, I really don't know what exactly LCM is. I know it's a lowest common multiple, I guess. But the shortcut is, remember, you got a 2 written over here, put it over here. You got a 3 written over here, put it over here. That's the formula. Is that clear?
Yes, sir.
Yes. Yeah, clear, sir.
Okay. I said one more thing. Make sure that this is the simplest ratio. Just make sure this is the simple. I mean, 2:3 can't be simplified further. You can't really simplify 2:3, right? So remember to simplify this at the end. When you do the whole crisscross thing, simplify the ratio. Most of the time, it's going to be the simplest ratio. So for example, if I have, if I do another example, if I have, let's say, so I've got 10 4+, and I've got oxygen, and it's 2-. First, tell me what would be the formula of this compound? Like if you do crisscross, what would be the formula of this thing?
10 oxygen 2.
Yes, it's going to be exactly. I mean, if you do crisscross, it's going to come out to be 10 would be twice, and oxygen would be 4 times, right? But this thing gets simplified, and it's actually going to be 1:2. You don't usually write 1, so it's going to be SnO2. See now. So this one. Remember, you can use the spacebar to unmute yourself when you want to talk. You get a spacebar. So hopefully this is clear to everyone. Remember this, that you've got positive ions, you've got a bunch of negative ions. a positive ion and a negative ion, they attract each other, they form an ionic compound. And to figure out the formula, you do crisscross, and when you do crisscross, it has to be the simplest ratio. So that is one thing. Now there's another thing, which is that ionic ions, ions are not limited to, you've got certain ions which are known as molecular ions or polyatomic ions. So molecular ions, or we can call them polyatomic ions. They're also sometimes referred to as radicals, which I don't really like because they're not really radicals. So these descriptions are better. Does anyone know of any molecule that's an ion?
Ammonium, acetate, bromate, chlorate,
Okay,
cyanide.
Okay, that's fine. So we'll start with, I'll make a list of ions that you should remember. So starting off with ammonium, let's start with ammonium. Does anyone know what the formula of ammonium is?
NH4.
Okay, so it's NH4 plus 1. You've got carbonates.
CO3.
Okay, so you should remember them by heart and memorize them. Nitrate is what?
NO3 minus.
Okay, so it's NO3 with a charge of -1. Sulfate.
SO4 minus 2.
Okay, so 4 is -2. Phosphate is what?
PO4 minus 3.
Okay, so it's PO4 -3. And you've got other ones as well, like sulfite. What is sulfite?
SO3 minus 2.
-2. Nitrite as well, that's
NO2
minus
minus 1.
okay, there's a phosphite.
PO3 minus 3.
Okay, that's PO3 -3. And apart from all of these, somebody mentioned a few more. What's a dichromate 6 ion?
Dichloromate, Cr2O7 minus 2.
Okay, that's Cr2O7 with a charge of -2. What's magnate 7?
KMNO4.
Yeah, but the ion is MnO4 with a charge of -1, right? KMnO4 is the whole. Okay, so this is magnate 7 or permagnate 7. And then you have what's cyanide? That is Cn -1. And let me just be quick. Are there any other ions that we've actually missed? Does anyone know any other ions apart from these?
Hydroxide.
Hydrogen carbonate.
Okay, so we've got hydroxide, that's the main one.
Which is OH minus 1.
OH -1. You've got hydrogen carbonate. What's the other name for hydrogen carbonate? It's also known as bicarbonate.
Bicarbonate. Perchlorate.
Just a second. It's CO3. No, you don't need to remember perchlorate and bromate, etc. You don't really need to remember those. Hydrogen sulfate is another one, which is HSO4 -1. And that's HSO4 -1. So I'll probably, let's keep it, that should be enough, I guess. Those are the main ones. I mean, there are obviously infinite other polyatomic ions, which you don't really need to remember as such. Now, first thing, I'll just give you a brief idea about these. These are basically molecules that their outer shells are not getting complete, so they end up gaining or losing electrons. So what I'll give you one example, like how does a molecule, I'll just give you one brief background of one of them and that's it. And we'll move forward with equations. So let's pick OH minus 1. So I'll just give you an example, an outline of what is OH minus 1. So when it comes to chemical bonding, you got an oxygen atom, right? An oxygen atom has, it's in group 6, so it has 6 electrons in its outer shell, right? An oxygen atom is a non-metal. Non-metals, remember, they really like to gain electrons. Okay, so non-metals, they always try to gain electrons from other elements. So how many electrons can oxygen gain at the moment?
2.
Okay, so it needs 2 electrons. It's missing 2 electrons. And that's the maximum electrons that it can gain because there's only space for 2 electrons left. So what if it sees, let's say it sees a hydrogen atom. So what it will do is it will try to attract hydrogen's electron and try to gain that hydrogen electron. So it will try to pull this electron towards itself. But hydrogen is a non-metal as well. Non-metals, remember, they don't like to lose electrons. So what happens is that when it pulls that electron, the whole hydrogen atom gets dragged and it comes and joins the oxygen atom because the hydrogen is not willing to lose its electron. Remember, non-metals, they don't like to lose electrons. So the whole oxygen tries to pull the electron, so the whole hydrogen atom gets dragged and comes closer to the oxygen atom. Is that clear, this one? That's a covalent bond, right?
Yes, sir.
So what if you have, now oxygen needs one more electron, right? So what if we have another hydrogen atom? What it will do is it will try to pull that electron and the whole hydrogen atom gets dragged and you get 2 hydrogen atoms now, right? So oxygen's 2 electrons are complete now. It tried to gain those 2 electrons, but ended up sharing those 2 electrons, right? So what molecule is this? This is the water molecule, right? Now, sometimes what happens is, instead, you don't have another hydrogen atom. Instead, you have, let's say I have a sodium atom. And remember, sodium is a metal. Sodium is a group 1 metal. And it's got 1 valence electron. So it's got this 1 valence electron, right? So oxygen at the moment needs 1 electron, right? It needs 1 electron. Its outer shell is not complete. So what it will try to do is it's going to try and pull sodium's electron. So what will sodium do? Now, remember, sodium is a metal. So what will sodium do? What do metals like to do? They like to
Lose
Lose
electrons.
electrons.
So this time the whole sodium atom does not come along. What happens is metals, they really like to lose electrons. So the electron ends up, so the electron basically ends up with the oxygen over here. And what is the charge that sodium gets? It gets a +1 charge because it's a metal, it's group 1, it loses 1 electron, it gets a +1 charge. And what happened to this molecule? This molecule ended up turning into an ion. Why? Because it ended up gaining 1 electron. Instead of sharing electrons, it ended up gaining 1 electron, which is why it has a charge of -1. So the basic idea, you don't need to remember this right now, TK, we'll do this later, but I'm just giving you a very basic idea. What happens is sometimes a molecule is getting formed, it's forming covalent bonds, but it needs electrons. It's running out of atoms and there's a metal around. And that metal ends up losing electrons, giving it to that molecule. The outer shell is complete, but that last electron ended up turning it into an ion because the whole molecule ended up gaining 1 extra electron from outside. So is the idea clear what an OH -1 ion is? Is this clear?
Yes, sir.
Yes.
So all of these molecules, something similar to this, similar to what happened over here, happened with these molecules as well. But the good thing is you don't really need to remember too many details. When we do chemical bonding later on, we'll discuss a few of them in a bit more detail, but that's about it. No one is going to ask you about the structure of a nitrate ion or even a sulfate ion or a phosphate ion. They're not going to do that. A few of them will be discussed in detail, but later on. At the moment, you just have to remember that you have a hydroxide and it has a charge of -1. You have a hydrogen carbonate. This is the formula. This is the charge. You have a carbonate, it's CO3, and it has a charge of -2. So for now, just remember the formula and the name. So one by one, we'll just practice crisscross again. Remember, there's going to be a positive ion attached to a negative ion. Just 1 second. I says, remember, there's going to be a positive ion attached to a negative ion. That's how ionic compounds are formed. So positive and negative. The positive is usually written first and the negative is written after that on the right side. For some organic compounds, it's the opposite. Like carboxylic acids, the negative ion is written first and the positive ion is written after the negative ion. But usually, this is how things are going to work. So let's start with potassium carbonate. Potassium K, that's group 1. What is the charge?
+1.
+1.
Okay, that's +1. This is -2. So what would be the formula of this thing?
K2CO3.
Okay, so it's going to be K2 and CO3. You just have to do crisscross. Just bring the 2 over here, get the 1 over there. So what basically happens is what this 1 means, don't bring the charge. What I mean by bringing this 1 over here is that the carbonate ion, which is this one, there should be 1 of them. Okay, that's what I mean by this, that there should be 1 carbonate ion. When I say that the 1 comes over here, and you don't need to write 1. Okay, remember, because even if you don't write this, there's still 1 carbonate. So this would be redundant. You don't need this extra bracket over here. The 2 over here means that there should be 2 potassium. So you don't bring in the charges when you're doing crisscross. Let's do another one. Let's say I have aluminium carbonate. So that is going to be, this is group 3, that's +3, and this is CO3, which is -2. What would be the formula in this case?
Al2CO3.
Again, this one. Al would be 2, right? So there would be 2 Als, right? Bring the 2, there's going to be 2 Als. How many carbonates would there be? 3, right? So you write CO3, put a bracket around it, and then there's going to be 3. Is that clear? Okay, the whole thing is, there would be 3 CO3s. Is that clear?
Yes, sir.
Okay,
Yes.
So just remember, be careful with polyatomic ions. Like if you want to make it twice or if you want to make it thrice, put a bracket around it and then do that. So let's say I have ammonium sulfate. What is the formula of ammonium sulfate?
NH4
So, what was the
No,
formula
no,
of this?
no.
It's going to be NH4 and then SO4.
Okay, so this means NH4 is going to be twice, right? So NH4, put a bracket around it, and there's going to be 2 of them, right? And how many sulfates?
1.
Just 1, right? So it's going to be SO4 and bracket 1. Obviously, you don't need to write this one. That's not required. Just write SO4. That's still 1. So it's going to be NH4 twice and NSO4. What about what about aluminium hydroxide? Aluminium is group 3. What's the formula?
Al(OH)(3).
So here this is -1 and it's going to be Al. Al is going to be 1. You don't need to write 1. And OH would be thrice. I said a lot of people sometimes, I frequently see them miss the brackets with OH. a lot of people think that over here there's no bracket required. You can just write AlOH3. But remember, if you don't write a bracket, that would just look like that there is a 3 next to H. That's it. Not with the whole OH. So you have to put a bracket explicitly around it and say that there's 3 OH ions and there's 1 aluminium ion. So is this part clear? This crisscross method, is this clear? I'll give you a worksheet after this. So that's a crisscross method. Remember, you remember these ions. Now, naming them. Just a bit about naming. Okay, let me just. I mean, the polyatomic ions are called the same names. Their names don't change. If there's ammonium in it, you call it ammonium. If there's phosphite in it, or phosphate in it, or cyanide or magnate, you just call it the same thing. But for the negative ions of the elements, the name changes. So make sure you remember this, that the negative ion of a non-metal so its suffix changes and it becomes an IDE. So the suffix changes to IDE. So for example, if I have Cl-1, what would I call it? I mean, Cl is group 7, so it's going to be -1. What was the name originally of Cl? I mean, what is Cl?
Chloride.
That's I mean, it used to be chlorine, but now it's not going to be chlorine. Suffix is the ending part. So that part will change. Instead of chlorine, it would be chloride. Do you remember that? That the name of the negative ion of the non-metal, its name changes. What would be oxygen, which has a charge of -2? What would you call this?
Oxide.
Okay, that's oxide, and so on. Phosphorus has a charge of P3-, it's in group 5. What would you call this?
Phosphate.
The IDE. Okay, so remember this. An IDE is only for the element. Phosphate ATE is something else. When you've got oxygen with it, it's going to be ATE. If you've got oxygens, it's going to be ITE or 8. So that is not the element. So IDE comes in when you just have the element. That's it. So this is phosphide. If sulfur has a charge of -2, you would call it what?
Sulfide.
Okay, so it's going to be sulfide. So make sure don't confuse IDE with the polyatomic or molecular ions that you've discussed above. IDE means just the element. Okay, so if I have nitride, what is the formula we're talking about? If they refer to something as nitride, so they're basically talking about just nitrogen, nothing else. And nitrogen is in group 5. So what is the charge? That's -3. Is that clear?
Yes.
Yes.
So just remember, don't confuse nitride with nitrate or with nitrite. It's IDE. That's just nitrogen. That's nothing else. So this is the only place where the name changes. That's it. Otherwise, the name pretty much remains the same. This is potassium carbonate. This is aluminium carbonate. This is ammonium sulfate. This is aluminium hydroxide. But over here, this would be aluminium. And instead of oxygen, it's going to be aluminium oxide. This would be tin with oxygen. So it's tin oxide. The non-metal negative ion, its name changes. So just make sure you remember that. Okay, so we're done with formulas. There's some formulas for covalent molecules, which I guess you should know, like the common ones. I mean, you should know what water is, right? you should know what carbon dioxide is. We're done with ionic formulas. How to make those ionic formulas. Covalent, pretty much you just have to remember most of them. It's so what is I'll just write a few of them. Ammonia is NH3, right? Hopefully everyone knows what ammonia is. And just hold on a second. So I guess everyone knows ammonia. What ammonia is: water is H2O, carbon dioxide is CO2, carbon monoxide is CO. I mean, the name kind of tells you what this is. Hydrogen peroxide is H2O2, right? And there are lots of other organic molecules like ethanoic acid, butanoic acid, which we'll study later on. But I'm just referring to the common ones that we need for the equations at the moment. So any others that we are missing? There are lots of acids: hydrochloric acid, sulfuric acid. So we're going to start talking about them now. So we'll start talking about equations now. We'll start building a first equation. And sorry, just a second. Can you guys hear me?
Yes. Yes, sir.
I said, so let's start with equations. Now things will slightly get difficult. Remember, you're already done with most of these equations. They have to be on your fingertips, but so we'll start revising them. And most of I'll first make a list of all the equations that you've studied in O-levels. For example, there's a metal plus acid equation. Let's start with number 1. We're not going to do them right now. We'll just make a list of equations. What happens when a reactive metal reacts with an acid? What is produced?
Salt plus hydrogen.
So that's salt plus hydrogen. So we've got salt plus H2 gas. We'll discuss this later. What happens when a metal oxide or a hydroxide, which is basically a base? So a metal oxide or a metal hydroxide reacts with an acid.
Salt plus water.
So that one is, so this one is salt plus water. What happens when a metal carbonate reacts with an acid?
Salt plus water and carbon dioxide.
So you're going to get salt, water, and carbon dioxide. What happens when you have ammonia plus acid? And remember, ammonia is also basic. It's ammonia plus acid.
We're just going to get a salt, ammonium salt.
Ammonium salt, yeah. So you're going to get an ammonium salt. Don't worry, we'll do this. We'll practice all of these. Number 5, what happens when you have an ammonium salt reacting with a base?
Salt plus water plus ammonium gas. Ammonium gas.
Ammonia gas.
Ammonia gas.
So it reacts with a base. It produces salt, water, and NH3. Is there any other reactions involving acids? What happens when this thing, base, carbonate, ammonia? Are we done with most of the acid-base reactions? What happens when you have a reactive metal reacting with water. And it has to be a reactive metal. So, I mean, like if you add sodium to water, it's going to form sodium hydroxide anyway. And depending if it's soluble, it would also form an oxide. Plus hydrogen gas would be given off. Number 7, let's any other reaction. What about decomposition? What happens when a carbonate is decomposed? A carbonate or a nitrate. What happens when a carbonate is heated strongly?
It
Anyone?
produces a metal oxide and CO2 gas.
Okay, so it's going to produce metal oxide plus CO2 gas, right? What happens when a metal nitrate? I said group 1 is not in your course, so I don't really care about group 1. Just a normal metal nitrate. What happens?
A metal oxide and nitrogen dioxide.
And one more thing, what is that?
Oxygen.
Oxygen as well. So it's going to form metal oxide plus NO2 plus oxygen gas, right? This is O2. Any other, I'm keeping organic chemistry out of this right now. So any other reactions apart from these? There's a metal hydroxide decomposition as well. What happens when you decompose a metal hydroxide, when you heat it strongly?
We get metal oxide and water.
Okay, so you're going to get metal oxide plus water.
So neutralization reaction, acid plus base.
That's metal oxide, that's a base. All of these are kind of neutralization reactions. These are bases. Ammonia, carbonates are basic. Metal oxides, metal hydroxide is a base. So base plus acid produces salt plus H2O. Is that clear?
Yes, sir.
So let's stick to these 9 reactions. The more common ones are, these are the more common ones. So let's stick to these 9 reactions. So if you're ever asked to make an equation, they're not going to give you an equation. You should know how to write an equation. Moles and stoichiometry is all about, you should have a balanced equation first, and then you start with the question. Anyway, so we'll start discussing each one of those equations one by one. Most of the equations are going to be written in kind of the same way. But let's start with these equations now. I'll come back to this and we'll start writing equations. But before writing those equations, we just need some background, because a lot of these equations are about acids and bases. So what is an acid?
A proton generator.
So it's a proton. And what is a proton? Proton is basically an H+1 ion. So it's a proton donor, right? And what's a base?
Proton acceptor.
That's some random molecule that is capable of accepting a proton or accepting an H+1. So remember, there are infinite possible molecules that are acids, and there are infinite possible molecules that are bases. Anything that is capable of releasing an H+1 ion, that's an acid. Anything that's accepting an H+1, that's a. So this definition is a very broad definition. You just study a few acids and you just study a few bases. That's it. But the definition is extremely broad. It covers a lot of different molecules. And also remember, this specific definition, if you Google for acids and bases, there are multiple definitions out there. Some of them are kind of not very broad. Some of them are really broad. This one is known as a Bronsted-Lowry acid-base definition. And this is the one that's in your course. So don't get confused when you hear the term Bronsted-Lowry acid-base theory. This is it just means the same thing that you already know. So you might get a question that according to Bronsted-Lowry acid-base theory, what is an acid? So it's the same thing. So it's so just remember Bronsted-Lowry acid-base theory. This is the definition according to Bronsted-Lowry. And there are other definitions out there which are not in your course. Now there's one question, and that is acids and bases are extremely important in chemistry. It's they're very, they're probably, this acid-base concept is one of the most important concepts. Now, can anyone explain to me why is H+1 ion over here so important? Like, why is it so important that we need to know who's giving off H+1 ions and who's accepting H+1? Why not any other ion? Why is this H+1 so important? Yeah, what's the reason for that? Like, why do we have a separate chapter for that? Why not somebody losing chlorine ions, somebody accepting chloride ions? Why is this H+1 so important? And why is acids and bases so important? Apart from the equations, there are obviously reactions happening, but why is it so important? Okay. Anyways, we're out of. Does anyone know any answer for this? Any guesses?
pH level. It controls the pH level.
What is the pH level? But it's, pH is important. pH is the same thing. Like pH is measuring H+1 ions, right? So my question is again, pH going below 7, that means there's a lot of H+1 ions. pH going above 7, that means there's a lot of, there are very few H+1 ions. So again, the question is, why is H+1 so important that you have to even measure it every time?
Is it like H+ ion is the ion which will make any substance an acid?
Yeah, but that's the whole question. Like, why is acid so important? I'll just give you a brief hint that we'll discuss this in detail in the next class. It's not that, this thing, no one is going to ask you about this anyways, but basically water is important. Everything on planet Earth, it revolves around water. If all the chemistry that's happening inside me at the moment, that all the molecules are basically floating around in water. All the plants, all living organisms, everything is dependent on water. Wherever there is no water, there is no chemistry happening. If you go to Sahara Desert, all reactions are not happening. Why is there nothing happening on the moon? Because there is no water there. Why is there nothing happening on space? Because molecules are basically bumping around, but they need a medium where they could float around and they could collide. So my body is 70% water. My blood, all the molecules, all the red blood cells, white blood cells, they need a medium through which they can flow. So all the chemistry that's happening around you, it's happening mainly inside water. Obviously, there is some chemistry that's happening in the air as well, in the atmosphere as well. Molecules need to bump into each other, but usually water is the medium that provides it provides that playing ground where all the molecules can interact. So I think we'll discuss more on this in the next class. We're running out of time. Just remember, I'll send you a worksheet as well on this, on these crisscross methods. You can try and complete that. I'll post it soon, probably in a few hours, related to crisscross. TK, make sure you do that. TK, any questions about this? And in the next class, we'll try and focus on these 9 equations. Okay. So let's continue tomorrow then.
Okay, sir. Thank you.
Okay, take care.
Allah Hafiz.
Hafiz.